Welcome guys to our class on surds, indices and logarithms. I won't be going through the laws of each topic in this video as I have already been through it in the written presentation. So let's start off with surds with our first example, in which we are given to simplify the root of 243 minus the root of 12 plus 2 root 75. The first thing you will look to do here is to simplify it to get each variable to be a multiple of a common surd. So if you look here, you can see that 12 is divisible by 3, 75 is divisible by 3, and 243 is divisible by 3. So with doing that, we can rewrite 243, 12, and root 75. So let's go ahead and do that. 243 divided by 3 is 81. So we rewrite that as root 81 times root 3 minus, we're going to split the 12, which will be root 4 times root 3 plus 2 root 25 times root 3. So as you look here, you can see that we can further simplify. We can find the square root of 25, 4, and 81. So that will give us 9 root 3 minus 2 root 3 plus root of 25 is 5 times 2, give us 10 root 3. And then what we do here is we see that we can factor out root 3. So let's do that. So this will give us 9 minus 2 plus 10 all multiplied by root 3. Right? And now that will give us 17 root 3. And that there, guys, is our answer. Let's go ahead and do a second example, which we are given to simplify root 50 plus root 8 plus root 32. When you look here now, you can see that all number can be divided by 2. So we can simplify that to make all a multiple of root 2. So we'll go now, and this will give us root 25 times root 2 plus root 4 times root 2 plus root 16 times root 2. And now we're gonna find the root of 25, 4, and 16. This will give us 5 root 2 plus 2 root 2 plus 4 root 2. And then we factor out the root 2, which will give us 5 plus 2 plus 4 times root 2, which is 11 root 2. And that is our answer. Now we're gonna move on to what we call the rationalization of the denominator for surds that cannot be solved using this method. So First thing I'm going to show you is one of the rule when you're rationalizing the denominator. The rule says that if you have root m plus root n times root m minus root n, this would be written down to root m square minus root n square, and the square root and the square would cancel each other, so it will write down to give you m minus n, m and n. So when you see the surds in this format, you can skip a few steps because you know that it's gonna write down to give you m minus n. So knowing that, we're gonna start by doing an example which is given as simplify 4 and root 7 plus root 3. When you're rationalizing, what we do is multiply the numerator and the denominator by opposite of the denominator given. So this would be, if you're going to rationalize this, it would be root 7 minus root 3 over root 7 minus root 3 times. And remember guys, by doing this we do not change the original function given, right? Because this would cancel, we get 1, which is 1 times the original function, it would be the original function. So we do not change the function, we just apply this method to simplify it to give us our answer, but we do not add, change anything that is given. So let's go. This will be equal to root 7 minus root 3, and from the denominator with the previous rule over here, we're gonna use it. So this will basically give 7 minus 3, right? Because this will just give us the root 7 square minus root 3 square, and the root sign would cancel with the square sign, which will just give us 7 minus 3. Okay. So now you can see that this would give us 4 root 7 minus root 3 on 4. These 4 will cancel, so our answer is root 7 minus root 3. Next guys, we're gonna move down to solving exponential equations, right? For indices, all the laws are in the written presentation, so, and they are clearly explained, so I won't be going through that in this video. So we're gonna go to solving exponential equations. Our first exponential equation is given as 2 to the x equal 32. So what we try to do here is, by using the law that states that if you have a to like the x, for example, is equal to a square, we can just equate the powers, because on each side of the equal sign variable is the same, so we can just equate the powers, so x will be equal to 2. So using this law, by understanding this law, you can be versed in exponential equation solving. So let's finish this question. So what we're gonna do now is try to bring 32 to the same base number as 2 to the x, which is 2 to the 5th. Therefore x is equal to 5. Alright? Now we're gonna work on another example. Let's call this example example 2, which is giving us 4 to the x plus 1 is equal to 0.25. So we're gonna look and say 0.25. How can we bring that to 4 to have the same base number as x plus 1? So 0.25 is the same as a quarter. So we can rewrite that as 1/4. And by using the law of indices, we can then rewrite this to x, 4 to the x plus 1 equal 4 to the minus 1. Right? Therefore, now we can equate the powers. So x plus 1 would be equal to minus 1. So x would be equal to minus 2. That's your answer. So to do exponential equations, you need to understand the laws of indices. Okay guys, so let's go where we're gonna solve a longer equation. So that equation is giving us 2 to the 2x plus 3 plus 2 to the x plus 3 is equal to 1 plus 2 to the x. Right? The first thing we're going to do now is use the law of indices. So we're going to try to reverse, go back to what the function would look like before we apply the laws of indices. Right? So we're going to basically like dismantle. So this, if we reverse the laws of indices, this would be 2 to the x times 2 to the x times 2 to the 3 plus 2 to the x times 2 to the 3 equal 1 plus 2 to the x. Right? Because I know the laws of indices, if you multiply like say a to the 1 times a to the 2, you can just add the power. So the answer would be a to the 1 plus 2, which is a to the 3. So let's continue. We're gonna to simplify this, we're gonna let y equal 2 to the x, because what we're trying to do is to get a quadratic equation. If you get a really complex question in which, let's say, you see that you're gonna get like a cubic equation where it's to the third power, then you just use the same thing. Just let y equal 2 to the x. And if I get the cubic equation, we just continue to simplify. So we're gonna let y equal 2 to the x. So this would give us now y squared, 8y squared plus 8y equal to 1 plus y. So we're going to carry over all of this from over the right hand side because we want 0 to be on the right hand side. So 8y squared, 8y minus the y coming over, this would be 7y minus 1 equal to 0. Right? To solve this for the factors, we can, let's say, we need two numbers when you multiply to get minus 8, and when you add it to get 7. Right? Which is 8 and minus 1. So we can just rewrite this as 8y squared plus 8y minus y minus 1 equal to 0. Right? And we're going to factor out 8y, which will give us y plus 1. Factor out minus 1, which will give us y plus 1. Right? So our two factors would be 8y minus 1 and y plus 1. Right? So by equating both of these to 0, 8y minus 1 equals 0, y equal to 1 over 8, and y plus 1 equals 0, y equal to minus 1. Right? So to find our third factor, which is the value of x, we can say use this equation where we let y equal 2 to the x. Okay, so we're gonna say when y equal 1 over 8, 2 to the x is equal to 1 over 8. Right? So now we're gonna try to use the method in which if the base number on both sides of the equal sign is the same, we can just equate the power. So that's what we're trying to reach here. So let's say 2 to the x equal 1 over 2 to the 3. Right? So 2 to the x is equal to 2 to the minus 3. Therefore, equating the powers, x is equal to minus 3. Right? And that is our answer, guys. Now, we're gonna solve an exponential equation which is in the form of simultaneous equations. So they said that if 3 to the x times 9 to the 2y is equal to 27, and 2 to the x times 4 to the minus y is equal to 1. 1 and 8. Find the values of x and y. So we need x and we need y. So let's go and see what we can do here. So we're gonna start with equation 1. 3 to the x times 9 to the 2y equal 27. Again, we're gonna try to get all of the base numbers to be the same so we can equate the powers. Right? If you see here, 3x is already in the right form, so we're gonna change 27 and 9 into multiples of 3's, so we can do it. So this will be 3 squared 2y equal to 3 to the 3, and this will give us 3 to the x times 3 to the 4y equal 3 to the 3, right? So using the laws of indices now, we can say this is 3x plus 4y equal 3 to the 3. Therefore, equating the powers now, x plus 4y will be equal to 3. So we're going to call this equation 3. Right? So now moving on to our second equation. Okay. This is equation 1. Equation 2 now, which is 2 to the x times 4 the minus y is equal to 1 and 8. So we can clearly see that all of these are multiples of 2. Right? So what we're gonna do now is bring back the 2 to the x times, this will be 2 to the 2 times minus y in the power equal to 1 over 2 to the 3. So 2 to the x times 2 to minus 2y is equal to 2 to the minus 3. Using the laws of indices again, this would give you 2 to the x minus 2y equal 2 to the minus 3. Therefore, x minus 2y, equating the powers, equal to minus 3. And this, guys, is equation 4. So what we're gonna do now, using simultaneous method, is to subtract equation 4 from equation 3. So we're gonna subtract equation 4 from equation 3 to x plus 4y equal to 3 and x minus 2y equal to minus 3. We're gonna subtract these, so the x would cancel. 4 minus 2y would give us 6y equal to 3 minus 3 would equal to 6. Right? Therefore y equal to 1. Right? So to find the value of x now, we can either put y equal 1 into equation 3 or equation 4. But we're going to use equation 3. So therefore, x plus 4y is equal to 3. X plus 4 between y and 3. So x would be equal to minus 1. Right, guys? And that is our answer, as we have gotten the value of x and y. Our next topic is logarithms. And as I've said before in the previous two topics, I've already went through the laws of each topic in the written presentation, so I won't be doing that in this video. In this video, I'll only be working tutorial questions. Okay. So our first logarithm questions state that without using calculator, evaluate log to the base 10 of 41 and 35 plus log to the base 10 of 70 minus log to the base 10 of 41 and 2 plus 2 log to the base 10 of 5, right? So as we look here, we can see clearly that we can apply the laws of log working from the left hand side to the right hand side. So let's go. First we're gonna break it. We're gonna work this group of log first, then we're gonna subtract this group of log using the laws of indices. So this would give log to the base 10. As they multiply, we can just, as they're adding, we can just multiply and keep back log to the base 10, which will give us 41 and 35 times 70, right? And then now we would subtract, and we're gonna use the same law on this side while subtracting. So this, we can write this as log the base 10 41 and 2 times 5 squared, because it, using the laws of log, if there are constant between before the log, we can bring it up into the power of the number being log. So if we are like 2 log to the base 10 of 3, we can rewrite that as log 10 log to the base 10 3 squared. So we can just bring up the